Hello. I am. People call me Seven, but it's Stephen Waterhouse. I'll do my own intro first. So I've been doing cryptos since like 2013. I met Greg shortly after that. I used to live in San Francisco. I was one of the co-founders of Pantera Capital, and then in 2017 started what people now would call a DePIN. It's a decentralized VPN called Orchid. For the last couple of years, I've been living in Lisbon after moving from San Francisco, doing a lot of continuing to run Orchid, but also investing as an angel investor. And recently, I started a venture fund focused on AI, not crypto AI, but AI, of which crypto will be part of it, called Nazaré, which is named after the really big waves in Portugal. I got into AI in the early 90s. I was building recurrent neural networks for speech recognition in my PhD. So I've been was very disillusioned with AI, and then it got super interesting again recently once we stopped just mining user data. I'm here to talk about decentralized business models, and if that is a thing, and I have some very interesting people here with me. So I had the chance to do my introduction. I'm going to let each of you do a little introduction and pump your bags for a bit. And then after that, there'll be no more pumping of bags, and we're going to get into some good conversation and debate. So this is your chance from the beginning, Hansu.
Yeah, you just heard me talk. So co-founder of Exhibits. Happy to continue and the discussion, the panel.
Hey, I'm Ben, co-founder of Jensen. Very brief background on me. Started out originally in AI as well. So did my PhD in deep learning, focused on optimizing the structure of neural networks back in 2015. Long story short, that's ridiculously computationally expensive, and showed me the kind of what we were going to see when AI got more popular in terms of resource constraints. And so fast forward to now, Jensen is a layer 1 protocol for accessing machine learning compute power, so doing operations on any compute device in the world that's capable of doing ML operations, essentially. So the idea is if you have a device, GPU, TPU, whatever it is, you can run our network and you can provide access to that device. Somebody can run ML ops on your device. On the flip side, if you're a machine learning researcher, engineer, anyone training a model, you can train a model on any device in the world or any subset of the world's devices instead of having to go through a cloud provider.
My name is Greg, the co-founder for Akash Network. Before Akash was primarily doing open source, been a contributor to Kubernetes ecosystem, wrote a lot of libraries that are still very actively used by the ecosystem, and really founded Akash to democratize cloud and compute, because compute is the fabric that connects the modern society, and that controlled by a few people that are unelected, that take tax from us, is not a future that I want for me. So I started working on the idea of super cloud. I mean, really, Cornell, popularized the idea, created the idea, but we popularized it, and we created Akash as the world's first super cloud. And and part of that journey, we also I think, figured out how to do a business model for open source software. We call it a tokenized open source software, right? So a big challenge today with open source software, be it Kubernetes or whatnot, is contributor churn. So we have contributors that come and contribute, but they don't stick along because there's no sustainability mechanism. We saw companies like Docker just run out of business after raising at billions of dollars of valuation. And the companies that lived had to take shortcuts and close source the software, call it open core, but not stay true to open source, right? So the challenge is, how do we really create open source, stay open source without taking shortcuts, right? And that was one of the big things that we figured out at Akash. I'd love to get into it, and it's been widely celebrated now, and Silver Lining's sort of a big piece on it, and the whole open source world is actually waking up to this idea of like community-funded projects with strong governance. And I think crypto as a primitive, the money primitive in crypto makes it gives us new properties that we haven't, thought were possible when it comes to open source business models that allow to chat today.
My name is Shannon. I'm head of growth at LivePeer. My crypto journey began somewhat unusually in 2011. I was regulating Bitcoin as a financial crime in Canada's finance department. Worked at the World Economic Forum, Thomson Reuters, lots of really centralized, not open source business model projects. I joined LivePeer, and prior to that, when I entered the Web3 space, had my own DAO protocol and tooling project, really passionate about actually decentralized governance and global coordination business models, having seen the dark side of what's possible in the other world. LivePeer, launched in 2017 as one of the first Web3 infrastructure projects. It's a decentralized GPU network of transcoding node operators. The network has built software for developers on top of that network to put video features and applications for live streaming and on demand. The software that's built on top of the LivePeer transcoding network is up to 50 times cheaper than building software on top of a cloud instance or AWS server. And we began our foray into the AI space earlier this year, with the launch of the AI subnet, which our head of network engineering presented on just after lunch. I'm really excited to talk more about that and how we're focused on the video and media use cases for decentralized AI.
I got one. Thank you. So I was just reading this thing over the weekend by David Kahn. Has anyone read this article by Sequoia? So a couple of years ago, he called it the $100 billion hole in terms of AI expenditure on infrastructure versus projected revenue. And this was factoring in a pretty healthy revenue from OpenAI, et cetera. He now estimates that it's a $600 billion hole. And this isn't like $600 billion we have to kind of make up. It's actually ongoing every year. One of the promises, or potential promises, and one of the reasons that people, when they think about investing in crypto/AI or decentralized compute, is the idea that the people in this room and others can make that $600 billion hole be a smaller hole, potentially. So instead of like just filling in with applications, which is one thing that's happening, you can actually make the cost of these things less. So my question to each of you guys fight out who wants to go first. Okay, you go first. Is how does your application and framework address the cost of compute within the AI space? And that's the first question.
Yeah, I think more generally, this question of profitability, coming from a very traditional background and also recognizing that cloud computing is a very mature industry. It's been around for many, many years, and the incumbents, you have the large tech companies that dominate this, right? And what we see when we deal with our customers, both from Web 2 and Web 3, is that because cloud computing is a very mature product, typically what they're looking for is very uniform and extremely clear in terms of what they expect for user experience and also what sort of minimum acceptable SLAs might be. And I think in addressing that, one of the reasons why we have, even though we have customers who are decentralized marketplaces, our infrastructure, the compute infrastructure itself, to be quite frank, is very much centralized. We're in the business of operating large-scale data centers, and we're looking to acquire more assets and deploy them on centralized data centers. That also consist of idle crypto miners and what have you. And so for us, I think in the end, the profitability and sort of the value proposition of decentralization in compute is not going to be just limited to the spatial, the actual product decentralization of chips being in the hands of individuals, and how do you coordinate the cost to bring efficiencies. Because at the end of the day, centralization, the reason why things are centralized is because the networking, the broadband connections, and everything is actually much more efficient when they're clustered. We just see a lot more opportunity in the ownership decentralization into financing these assets that are, of course, very much in demand and extremely capital intensive. And I think that's one of the overlooked spots we think there are tons of opportunity.
Okay, thanks. Ben?
Yeah, I'd probably just kind of continue that with the message of the cloud computing market is just highly oligopolistic now because it's quite hard to enter as a new provider. It's got a lot better in the past maybe 2 years where we've seen, speaking specifically for AI compute, we've seen a lot of kind of new entrants. We've seen people like Lambda Labs become a lot larger. There's been new centralized providers that can actually stand up data centers and provide access to hardware. CoreWeave's a good example. And that has improved things, I think, on the kind of the cloud side, but it's still not driven down prices to where they could be. And the main reason we think is just that becoming a cloud provider and giving access to hardware, if you have hardware, is just a highly costly business, mostly administratively. One of the biggest pieces underneath that is trust. You have to be able to establish some degree of trust with the person that you're renting that hardware out to so that they know that you're going to do the work that you say you do. And wherever you source that hardware from, you also have to have that trust. And we can solve that in the current centralized world basically by throwing people and legal contracts at it. But that's a really expensive thing to do, and it's slow. So if you do want to stand up a new data center, you're a new provider, you want to start renting that hardware out to somebody, you have to put all of those things in place as a centralized business to be able to establish trust with customers and rent out that hardware. There's other things you need as well. There's infrastructure that you need. There's ways of getting the tasks themselves out to the hardware, all of these extra things that you have to build, rather than just being able to say, hey, I've got a GPU or something like that, and I want to give you access. I want to rent it out to you. So the kind of the benefit of decentralization we see is that you can replace a load of those centralized things with technology, essentially. You swap out the idea of a contract with code, you swap out infrastructure, like manual infrastructure again with code, and in doing that, you can crucially solve the trust problem in the decentralized way, but you can also replace all of these just highly expensive things that somebody has to do to be a cloud provider with just running some open source software. And that brings down the cost so much that instead of having to have a data center or multiple data centers before it's viable to be a provider, you could actually just be a person at home with some hardware that says, hey, I'm actually going to become a cloud provider, but I'm just going to do it by running some open source software. So decentralization gives us the ability to basically make everybody a cloud provider, which results in enormous amounts of competition against the current oligopolistic market.
Yeah, so to specifically address the question about $600 billion hole, right? If you think about it, Amazon makes about 43% margin on compute, right, on average. So if you remove Amazon, you remove 43% at least. So there are three aspects. You have essentially the cost of the chips themselves, number one, right? Number two is you have the middlemen, the cloud providers, making money. And number three is you essentially have isolated islands of chips that are not shared. So you either reduce the cost, or cut the middleman, or you make these chips more, profitable, right? Not just a model. So using a pooling mechanism, right? So OpenAI has chips, and Anthropic has chips, and we have chips, you have chips, everybody has chips, right? You know, if we all share the chips amongst ourselves, we can create a much cheaper world because now we don't have isolated clusters, but rather a shared cluster, right? I think compute should be a common good. When that happens, the costs will be significantly lower because now we don't need new chips coming from NVIDIA as much as we are needing now, right? It's the access problem. And number two, diversify from a technical standpoint as well, right? And I think that's where the open source comes into play. We've been experimenting. NVIDIA is the king, obviously, and their profit margins are incredibly high. The actual cost of the chip is not as much what NVIDIA sells them for. NVIDIA does so because, well, it's a monopoly, right? Break the monopoly. How? Well, you got to get better or cheaper chips or from competitors like AMD. There's one project that we're working on. In fact, not we're working on, this person called George Hotz, or Geo Hotz. He's a famous hacker. He is rewriting the drivers for AMD to make it usable because AMD sucks in the drivers and the code. And so with MI350s, they are retrofitting, which has 120 gig memory, on-chip memory, so which is a really, really good chip. And he sent us the first box, by the way. The first ever tiny box is going to be on Akash. So things like that are coming, and that's going to reduce the cost significantly, right? So we can use AMDs. Yeah, ultimately, I think decentralization, open source is the solution to the cost problem, and we'll get there. Right now, centralization is too inefficient, and that's creating the hole bigger and bigger.
Yeah, I can talk about how, as a decentralized infrastructure network for supply and demand for video compute, LivePeer is really focused, I would say, more heavily on the demand side of the network, and really trying to understand the use case and user needs, and we really think that can drive down cost at the end of the day for end users. And I can talk about how pricing happens on the LivePeer network with respect to transcoding to actually result in lower, more competitive costs of services, and how we're thinking about pricing similarly for the AI network as well. So unlike data centers, which you have to rent kind of on a time unit basis, with LivePeer, you pay for compute on a job basis. So you pay for transcoding on the network per pixel. And then the hosted API service that has gone to market for the last few years has, abstracted that to pay for to charge per minute streamed on the network. So kind of using that methodology for pricing per job type on the AI subnet, we're also allowing our node operators to price per inference task on the network. So you can actually charge a different price for a text-to-image or a text-to-video. And really what this is about is creating radical transparency in cost and pricing. And I don't think that's possible when you as a developer are just having to rent an hour of time on a data center. So I think that level of precision and granularity to understand you're only paying on demand, quite literally, for the jobs you need a compute network to do for you.
Right, but that's kind of like a different abstraction layer, right? It's not. There's a couple of people brought this point up, but that's really just pricing mechanisms. So, you could charge these things on subscription levels. You could charge it on per job. You can charge it on, I get the SSH session. The other question I'm want to ask all of you, or just, I guess I'm going to fire us off to Greg first, is I remember some of the work you did around IONET and trying to get, trying to actually get an H100. Was it an H100 you were trying to get, or was it an A100?
I requested 4 H100s and I got an A.
Okay, so if anyone doesn't know, and apologies to anyone who's from IONET or invested, they suffered a rather unfortunate series of events, which led to kind of an interesting question around when you're renting a GPU, or even if you're trying to get as in your case, Shannon, talking about just doing a job, is how do you know what you're paying for? And this is something we focused a lot with Orchid when we were building decentralized VPNs, is if I'm sending a job into the network, how do I know that I'm getting it done by an H100? Do I have one of these machines? Do I getting what I'm paying for? I think when BitTensor started, people were just copying the outputs from one node and throwing it as another node and pretending they had the same answer, because the system was saying, well, I don't know, it's just, it's an answer, sounds good, here's some money. How do you think about that in terms of the proof, the kind of trust within these systems?
Right, so there are two ways the two parts of trust, right? One is just trusting the hardware during build time and trusting the hardware at runtime, right? Now, Ben has been working quite a lot on runtime, but we are using something called Trusted Execution Enclaves, or TEEs, to essentially verify whether the hardware that someone said they have do have it, right? So there's actually a proposal right now. It's not active on Akash. It's a proposal right now from a professor at UT Austin. And they're doing verifiable hardware. Akash doesn't have verifiability. It has a reputation system. And Akash doesn't have incentives because, well, we don't have verification. What IONET did is they enable incentives without verification, then you get Sybil attacks. That's, for a crypto network, you've done crypto for a while, you know if you put any incentive, you're going to have attacks. So that's why we chose not to do incentives until we have verification. Right? So people on Akash provide the GPUs, and there's threshold verification mechanism and like an optimistic approach where you pass the results to three providers, and by a quorum selection you can see whether you're getting back the results you're getting back.
You do like an optimistic approach to the...
An optimistic approach, and the reputation mechanism that tracks the fraud proofs, right? So. And now we're doing the TEE too, so along with the optimistic approach. And then we'll have enable incentives.
So yeah, just kind of for anyone who's not aware about this. So normally when you talk about trust and blockchain, everyone thinks, well, of course everything's trusted in blockchain. But when you get to layer 2s, there is no blockchain. It's just a bunch of computers like doing random things. And the only way you trust them is like either through ZK or through optimistic approaches. And we're all pretty familiar with the different mechanisms there. The same thing happens in decentralized services. So the stuff we're talking about here has the same spectrum of like either it's proved in some way, either through hardware or software like ZK, or you optimistically prove things. Ben, how do you guys think about these things?
Yeah, well, Greg put it well with we focus on the runtime approach. And essentially we think the gold standard to achieve is exactly verify exactly what the user is like purchasing. If there's a transaction going on, if somebody's giving up money for something, they're purchasing something directly, can we go right to that thing and make sure that they are definitely getting that thing? The kind of perfect system, theoretically, would be if you could create a cryptographic proof that the exact operations that the user requested and paid for have actually been performed in some way that's succinct and quick to do and not a huge overhead on top of the computation. Right now, it is a huge overhead on top of the computation, and then there's multiple things you can do kind of away from that, which bring the cost down and make it more viable. What Greg described is going quite far away from the ops themselves and essentially saying, okay, well, if I can verify that the person who's providing the device is definitely providing this device, then I can assume that in between, when they are requested to do tasks, they're probably using the same device. That's a reasonable assumption in some cases, and it depends on what task you're doing. If you're doing a task where you have a kind of medium degree of requirement for verification, that probably is okay. But if you're doing a task where the user really has to know what they're getting and they are vulnerable to attacks in other ways, then the user's going to want more kind of security. Jensen's approach is to stay at the runtime level, but do that kind of live trade-off of efficiency, essentially. So you can use optimistic approaches to then gradually kind of distill down from a full operation down to a chain and have a source of truth. You can throw in bits of those cryptographic proofs when you need to, but ultimately what you have is a system that uses multiple different pieces of kind of verification technology to give the user the highest degree of security. You can also trade that off live for the user, so you can say, hey, if you don't really care much about this task, you can pay less, you can have it done quicker. A bit like using Google Colab, you just I just need to throw something at a GPU and see how it's done, versus I want to do a big training run, I'm training the next like GPT model, this has to be done correctly, I'm willing to pay a 50% overhead, for example, to know that it was done correctly. So you can hand that to the user to a degree, but at the end of the day, underneath it is a load of different techniques all applied to make the most efficient system that's the most secure it can be for that efficiency level.
Right, and it really comes down to what you're incentivizing. If you're incentivizing the inference on the model, then it's a completely different, verification versus you're incentivizing someone providing the hardware, which is a hardware verification. Of course, that's not the only verification. There's optimistic approaches on top of that. There's a reputation system, there's auditing system, whatnot, right? So it's not a single bullet that's going to solve all the problems. It is a combination of primitives that we combine and hopefully reduce the error rate, right? That's really...
Hansi, how do you guys think about provability of how do you know what's in your data centers?
Right, So for us, as I said before, on our customer-facing side, we have a very traditional business model, right? We did follow what the existing cloud providers do. Now, and that wasn't because we didn't consider verification as an important element in our business at the very beginning of the formation of our venture. For us, we saw this triangle of trade-offs, okay? So performance you have at the top, you have cost efficiency, right? Getting things low cost as possible, and then you also have verification. And we acknowledge the fact that when you have verification, it increases your overhead and your compute load. And we're very glad that we have super smart guys like Ben and Jensen working and hacking away at the problem. But we made the bet that at the end of the day, we're going to be rewarded more for being cost efficient. And from that point, centralized data center infrastructure made a ton of sense. And of course, looking back, compute remains incredibly capital intensive. It's very, very expensive. And so it seems like that bet has been playing out pretty well for us. But I think related to that trade-off question, a really big question is, where is AI, advanced AI modeling headed? One view is it's all about scale, right? Is it going to be sequential ChatGPT 5.0, 6.0, 7.0, multimodality, where scale is everything that matters? Because obviously, if you have very advanced AI models that are incredibly generalized, it's always going to strictly dominate anything that's more specialized. But you can also think of an alternative future where AI becomes a lot more specialized, much smaller in scale, and you have a multitude of these different specialized models that different corporations are using, in which case I think there is a room, a much bigger fighting chance for focusing a lot more on the verifiability and decentralized compute infrastructure. And I think the jury is out where it's headed, because compute we haven't really found a way to figure out a viable competition to NVIDIA to bring prices down, and the sheer cost of training these gigantic models with trillion-plus parameters seems that there's really not any sort of sign of slowing down on that front.
Yeah, for LivePeer, I think there's two kind of high-level verification problem spaces. One that's already been discussed is the verification of work on the network and the verification of hardware. I would say we still have a ways to go in getting to full trustless verification on the network, and we're looking at ZK and other solutions to do that. When it comes to, again, kind of like media use cases and thinking about AI, we are paying a lot of attention and being really proactive around content provenance and authenticity. LivePeer is part of the Content Authenticity Initiative, which is run by Google and the other large providers, which is a trusted list of authorities who can credentialize content. We are also working on, obviously, looking at more cryptographic ways of, providing provenance and authenticity to ensure that, output into our AI network, can be traced through the life cycle of a piece of video and media content. So I think, those are two high-level verification spaces we're interested in.
I think if I could just link those 2 points, I think you're absolutely right. There's more resources that sit underneath AI, basically, than just compute itself. There's data as well. There's the kind of expert knowledge involved in building the models. There's general distribution of those models to users. But ultimately, we talk a lot about compute or hardware specifically, but there are other resources. And I think linking that to the scale point, realistically, ML is still quite early in what we can see that it can do. We've seen it have some really interesting effects with ChatGPT, but at the end of the day, it's a completely new technology that unlocks potentially unlimited new possibilities as a base level primitive, but we're constraining it on multiple fronts right now, and those multiple fronts kind of exist because of legacy business models. So if we can just rethink the way of accessing each of those core resources that sit underneath AI, we can actually unlock way higher scale, way faster execution, way more access to smaller businesses, to individuals building new models, et cetera, to people building models on different types of data that they couldn't before access. So we're in a really kind of early phase, but the business models that we've sort of described of decentralization exist for every piece of the stack. So people here will build different versions of them, but everybody else should be building them as well. And ultimately, the real kind of exciting thing is the combination of all of those different primitives at the bottom, allowing us to do ML at a completely different scale, not just Google putting 2 data centers together and building a bigger model, like all of us potentially providing our data, providing compute, and building a model that's bigger than that, but in a collective way that we couldn't possibly do right now, because we'd have to go and find a cloud provider that would like rent to like hundreds of different people at the same time or something. It's just not really possible.
But broadly speaking, from a verification standpoint, there's pessimistic verification, right, which is ZKML, essentially. Well, the trade-off is, well, it takes 40 minutes for to produce a proof for a stable diffusion 3.5. Sorry, stable diffusion 2.5. It takes a very long time to produce.
Ridiculous.
It's ridiculously expensive, very expensive.
The numbers you see are usually quite naive. They're throwing an existing like Snark method at something that isn't really that suited for it. So you can get a lot of efficiency gains with focus on hardware and just improvement of the like cryptographic primitives themselves, but not to make it free, to make it like 100x or 1,000x instead of like 10,000x.
I'm going to close with one question. Decentralized AGI, yes or no? And what day?
Whoa.
Yes or no on a day?
Decentralized AGI? Yes, in 60 years.
I wanted the AGI. I think AGI should be decentralized. I hope it will be, but the way the things are going right now, it doesn't look like it's going to be. You know.
You're supposed to believe in your own back. This is your chance.
Hey,
I
spent a lot of time on the Hill, and I don't want to say something that I'm going to be quoted on.
I'm relying on you saying something
AGI
like this.
is and will be decentralized.
Soon.
By timeline to be TBD.
Come in.
I think everyone's definition of AGI is different. Mine is just intrinsically decentralized.
Cannot move the goalposts. It's not fair.
No. My definition is basically like only decentralized, so yes. And some point in the next 4 or 5 years, I think.
Yeah, I mean, everyone has different definitions of what AGI really means, right? But I would say this. I would say I think the one test that everyone agrees on is the Turing test, and I think we've already gone beyond that. So in some sense, if you had asked someone like 70 years ago, when will we have AGI? I think we've already reached that milestone. But in terms of an AI that can really come out with new laws of physics, discovering new experimentally based facts, discovering new knowledge, right? This is what PhDs are supposed to do. When will we see an AI model that can do that? I think that requires a lot of advancements in robotics, because you can only deduce your way through having so much just based on data, existing data, but you have to do experiments and engage with the physical world. And I think that really requires very intense AI workloads that our current existing decentralized infrastructure networks are nowhere near able to swing. So I think it's a lot longer than what most people would hope, but the way that these technologies have been advancing, it can certainly come sooner than later.
All right, wrapping this up then. Thank you very much, all of you, the panelists. Big hand.